2, and we're looking at problem number 9. And I will come here. And we're looking at the integral from 2 over the square root of 3 to 2. And it's 11t. And then it's inverse cosecant of t dt. Okay.
2 divided by the square root of 3.
Yeah. Yeah. Oh, did I say 2 on? No, it's 2 divided by the square root of 3. Okay. And so what you'll do on this problem is you will recognize, I guess if this were, I'm trying to think if you're on the final exam, and this problem's not going to be given on the final exam probably because it definitely would have been given with definite integrals because you might be able to fudge your way into the correct answer if it's multiple choice. So I definitely would leave the definite part out. So, but I guess on the online you don't have a choice because it doesn't help you. Even though you can get it with a calculator, it doesn't help you. So there could be people out there that are using the TI-89 to do this work, and just know you'll probably fail the course if you don't know how to do this because you'll bomb the final by not being able to do it. So it's a good idea that you asked this one. All right, so if we're going to use integration by parts, which I'm kind of inclined to do because I seem to have 2 functions. I definitely seem to see 2 functions there. And I'm going to need to look at my sheet and see if I have an integral or if I have a derivative for the inverse or an integral or a derivative for the inverse cosecant that might help me. And I'm not seeing, so I definitely know the derivative for the inverse cosecant though, right? The derivative for the arc cosecant is, so if I let you, and I'm just going to, I haven't looked at the solution, so this may be the wrong approach, but I'm going to let u equal the inverse cosecant of t, and then I need to find du. All right, so du is, according to the sheet, negative, okay, it's a negative u prime, so this is whatever here, you take the derivative of that, which is just 1, over the square root of 1 minus, oh, I'm looking, you know what, I'm looking at, darn, I'm looking at cosine, cosecant is negative 1 over the square root of t squared minus 1, and it has the absolute value of t here. Okay. Okay, and now if I do dv is equal to t, then v is equal to t squared over 2. And this is a dt. Okay. All right, this is going to work. Now, I'm going to address a couple of things. Notice I didn't worry about the 11 because numbers can always just tag along up front. So I just put that 11 up front, and I'm just going to not worry about it. Okay. Now, remember the formula is uv minus the integral of the voodoo, right? So it's going to be u times v, which is going to be inverse cosecant t times the t squared over 2 minus the integral of the voodoo, which is v, which is t squared over 2 times du, which is negative 1 over the absolute value of t times the square root of t squared minus 1 dt. Okay, now don't worry, and you kind of have to that 11 is on all of that. Now, and then of course we're going to evaluate it from 2 squared to 3 to 2. This absolute value of t, we don't have to worry about, and the reason we don't have to worry about it being absolute value is because our limits are positive from 2 squared to 3 to 2, so we don't have to worry about that. And what happens then is we're able to cancel this with one of these. And then this actually becomes, so I have the 11, I have the inverse cosecant t times t squared over 2. And then this is going to become plus, and there's a 1/2, and then there's an integral, and then it's just t over the square root of t squared minus 1 dt, which is actually great because I can do that with just a u substitution. All right, so just to help me with fractions and computation, I'm going to pull out that 1/2 out of both of them. So I'm going to have 11 halves. I'm going to write this as t squared inverse cosecant t plus. All right, so here, if I let u equal t squared plus 1, minus 1, then du is equal to 2t dt. So I'm going to have another 1/2, and this will be the integral of du over square root u. So this is 11 halves, and then this is t squared inverse cosecant t plus, all right, so this is u to the negative 1/2. So you add one to the exponent and put it over it. So that's going to be 2u to the 1/2, right? Which will cancel with that. And so it'll just be u to the 1/2, and our u was at t squared minus 1. So this is 11 halves t squared inverse cosecant t plus the square root of t squared minus 1, evaluated from 2 to the square root of 3 to 2. I didn't make any mistakes. I feel like it's okay. Okay, now we'll plug in our 2 in our 2 square root of 3. So this 11 halves is just going to tag along at the very end. Okay, so this is going to be 4 inverse cosecant 2 plus the square root of 3, because it's 2 squared minus 1, minus this will be, when this is 4/3 when you square it, inverse cosecant 2 over the square root of 3 plus, okay, this is squared is 4/3 minus 1 is 1/3. So this is, okay, so this 4/3 minus 1 is 1/3, and you're going to take the square root of that, which is the square root of 1/3, which is the square root of 3 over 3. Okay, so this is 11 halves. Okay, cosecant deals with the sign, right? So that's the same as saying, when is the sign 1/2, which is at, because that would be when the cosecant is 2. The sign is 1/2 at pi over 6. So this is 4 pi over 6 plus the square root of 3 minus, all right, the 2 over the square root of 3 is the same as saying, when is the sine the square root of 3 over 2. which is at pi over 3. So this is 4 pi over 9, because it's 4/3. That's pi over 3. Okay. Plus the square root of 3 over 3. So this is 11 halves. This is, we'll get a common denominator here of 18. So this will be 12 pi over 18 plus, this is a whole, and it's going to be take away 1/3. So you're going to have 2/3 left. 2 square roots of 3 over 3 minus, this will be 8 pi over 18. And 12 minus 8 is 4. So this is 11 halves. This would be 4 pi over 18 plus 2 square roots of 3 over 3, which is, let's see, 2 goes into, better not, okay, 2 goes into both of them. So 2 goes into that one, it goes into this one 2 times. And then that goes in that 9 times. So 11 pi plus 11 square roots of 3. This over 9, this over 3. I don't know how simplified they want this. So you could write this as 11 pi plus 33 on the square root of 3 over 9. Ugh, I'm so scared. What do you think? Will it like it like that, or will it like it like this? Or you don't know? Which one? The top one? Should I try the bottom one just for fun? No? You've had enough. 11 pi, I'm going to try the bottom one just for fun, plus 33 on the square root of 3 divided by 9. They took it. Wow, that was a hard problem. Are you guys doing all that work, or are you just fudging it?
I got to about.
It's a really good one, because it really, I mean, you really had to apply the, you want me to go back over it? You really had to look at it again.
I got it till, how did you get the 2 on the square root of 3 over 3?
Oh, you got all the calculus?
Yeah.
You just had a bad trig teacher? Okay, how did I get the 2 on the square root of 3 over 3?
Yeah,
So right here,
how you get
I got a whole one. I've got one thing, take away 1/3 of it. So I've got 2/3,
Oh, okay.
right? You could think of this as 3 times the square root of 3 over 3 minus the square root of 3 over 3. Yeah.
Yeah, and I also couldn't remember
How to do the inverse cosecant of 2, and yeah.
I forgot that you flipped it.
Yeah. Yeah, that's a lot. That's a lot. I mean, because all of that was just previous knowledge, but it was actually, I thought, a pretty interesting problem within here, too. First knowing which ones to do.
Yeah, I got all that, but when we get down to the trig and the algebra, there's lots of it. That's where it scares me. So.
Yeah, I tell you that calculus makes you better at trig for sure. I mean, you know what I
I thought
mean?
it would disappear, but I was wrong.
You thought it would, like you wouldn't have to do it
All
anymore?
the trig stuff
Yeah.
would go away.
Yeah, because there's no reason why we would require that class before this class. That was a good one. No, I think